Hello, welcome to Astronautics for Exploit. This is Dr. Ayenshola Ogundele. Spacecraft ground segment scaling, a transition from traditional physical infrastructure to flexible, cost-effective, and cloud-based solutions. The focus points are as follows. Spacecraft ground segment scaling, importance of spacecraft ground segment scaling, spacecraft ground segment scaling methods, and future of spacecraft ground segment scaling. Over many decades, in a bid to meet the new space demands and current satellite constellations approaches, spacecraft ground segment scaling and evolution have been shifting from traditional rigid and proprietary hardware to flexible software-defined and cloud-based systems. Spacecraft ground segment scaling capability of an hard-based infrastructure such as antenna, software, and networks to adapt to be able to handle massive increases in data, complexity, and satellites in constellations is achieved via a transition from traditional and dedicated physical infrastructure to flexible, cost-effective, cloud-based, and on-demand solutions. The scaling is made possible via software-defined radio, artificial intelligence, and cloud computing technologies. It involves virtualization, adoption of ground segment as a service, leveraging of RF over IP, pay-per-use access, and a host of others. Scaled spacecraft ground segment helps to increase data downlink in comparison to traditional methods through global networks and optimized frameworks. Spacecraft ground segment scaling involves transitioning from traditional inflexible infrastructure to a more agile, cost-effective, and scalable solutions. The primary drivers are the increasing number of low Earth orbit satellites, which are mega constellations, and the demand for faster, higher volume data delivery. The primary approach to spacecraft ground segment scaling is the adoption of ground segment as a service, which is enabled by virtualization and cloud computing. LEO satellite constellations Starlink, OneWeb, Upcom, and Iridium is illustrated in this picture. Importance of spacecraft ground segment scaling. Managing large satellite constellations. As satellite constellations grow to hundreds or thousands of satellites, the ground segment must be able to handle a massive increase in commands, telemetry, and data traffic. Handling of increased data volume. Today's satellites, especially those for Earth observation, are equipped with more powerful sensors, leading to a demand for more bandwidth to reliably transmit vast amounts of data to the Earth for processing and analysis. NASA Space Network, made up of several tracking and data relay satellites, is illustrated in this picture. Ensuring flexibility and agility is another importance of spacecraft ground segment scaling. Scaling allows operators to quickly adjust ground station usage up or down based on mission needs, which can fluctuate rapidly. This is vital for evolving missions and business models. Enabling new applications. A scalable ground segment is essential for supporting new services and applications that require near real-time data, such as those in commercial, government, and military sectors. Ground data systems and mission operation is illustrated in this picture. Cost reduction. Models such as ground station as a service allow companies to access a network of ground stations on a pay-per-use basis. This thereby eliminates the massive upfront investment traditionally required to build and maintain a dedicated ground infrastructure. Adaptation to evolving technology. A scalable and flexible ground segment is needed to keep pace with the rapid advancements in the space segments, such as the rise of software-defined satellites. Australia's fleet of Internet of Things satellite communication ground station is illustrated in this picture. Spacecraft ground scaling methods. The scaling methods are virtualization, which converts ground segment functions to software, including digital radio frequency streams, allows operators to dynamically reconfigure systems and scale them up or down in order to meet fluctuating demands. Cloud-based services, a pay-per-use model which eliminates the need for large upfront investment in ground infrastructure. Traditional versus ground station as a service model is illustrated in this picture. Other scaling methods are software-defined radios and containerization. Software-defined radios allow modem to be reconfigured through software, enabling a single ground station to support multiple satellite missions without hardware changes. Containerization. Modern solutions use containerized architectures such as Kubernetes to deploy and manage ground segment components. NASA's new cutting-edge deep space antenna is illustrated in this picture. Drivers of spacecraft ground segment scaling are satellite proliferation and new orbits. The emergence of numerous new satellites, especially in low Earth orbit, creates a need for more ground stations, faster antenna switching, and higher tracking accuracy in order to be able to manage increased number of targets and data volumes. Shift to cloud and software-defined systems. Moving from specialized hardware to cloud-based software-defined networking and virtualization enables dynamic scaling, greater flexibility, and lower operational costs. Satellite connectivity is illustrated in this picture. Other drivers are increased demand for data and services and cost reduction and new business models. New applications such as Internet of Things and higher resolution imagery require more robust ground infrastructure in order to handle greater data loss and provide low latency. The demand for more cost-effective operations is driving the adoption of commercial off-the-shelf technology. Integrated ground system is illustrated in this picture. Other drivers are security and resilience. Growing geopolitical tensions and inherent value of space access make cybersecurity and network resilience very critical. Integration with terrestrial networks. The need to integrate satellite services with existing terrestrial infrastructure such as 5G pushes the industry towards common standards. This space outpost near the moon is illustrated in this picture. Advancement in technology innovations such as phased array antennas, which allow for faster handovers and edge computing, processes data closer to the source. Artificial intelligence and machine learning is becoming essential for managing complexity of modern ground segments. Cloudification of network stack for in-orbit of things in space, Internet of Things in space is illustrated in this picture. For more information, contact Astronautics for Exploit. You've been listening to Spacecraft Ground Segment Scaling, a transition from traditional physical infrastructure to flexible, cost-effective, and cloud-based solution by Dr. Ayashola Ogundele, with a focus point, spacecraft ground segment scaling, importance of spacecraft ground segment scaling, spacecraft ground segment scaling methods, and future of spacecraft ground segment scaling. Thank you.